So let's say that we compare shoe size and height to people in the class, right? Do you think that shoe size and height kind of go up together? It is kind of a linear relationship. So say I have the shortest person who has like size 5 feet in the class, and the tallest person is the tallest person in the class. Who's like 6 foot something? Tate, are you 6 foot something?
Maybe.
What size shoe do you wear?
Like 11 and a half.
11 and a half, so you have pretty big feet, right?
Yeah.
So we could use, anyone have bigger than 11 and a half size shoe? No? I have size 11 and a half size shoe, and they always told me I was going to be tall, but it never worked out that way. But for the most part, people with big feet tend to be taller, right? You go to a basketball game, and these guys have like size 15 and 16 size sneakers, the guys in the NBA and stuff like that. But you could use interpolation, okay, to figure out like you could graph this in a linear relationship and say, okay, if you're 5 feet 10, what size shoe you would wear based on a linear graph. Now, not everything is linear, okay? But when we're doing this, we're going to base it on a linear graph. Extrapolation is when you go beyond, okay? So say, for example, growth rates. Like when I was in college here many, many years ago, there were only like 10,000 homes in Louisville, or 10,000 population. Louisville was like 10,000, okay? Now, I don't know what do you know what the population is? It's probably closer to 30,000 or something like that. We could make a line and we could show a graph of that, okay? And you could extrapolation would be saying, okay, based on this linear relationship, what would be the population in 2050 or something like that? And that's extrapolation, is when you go beyond, okay? And so the difference between these two things, so interpolation estimates values between known points, and extrapolation predicts values beyond known points, okay? So you could do, so you could make a graph of things to figure things out. So in 2004, 12% of the students at the Dance Academy were enrolled in a music class. In 2009, that had risen to 18%. In 2012, it reached 22%. Estimate the percent of students enrolled in class in 2007. Anyone have any ideas what I should put on the x-axis? Should I put years, or should I put percent? Probably years, right? Because it's more like the percent is based on the years. And then you kind of have to figure out a scale, okay? And so what I would do is kind of start here at, call this year 2004, okay? So 2004, and I'd go maybe, let's see, they talk about 2012, 2009. I guess we have enough room to count every box as one, don't we? To that, yeah, we do. So if this is 2004, then 2009, 5, 6, 7, 8, 9. Okay, that'd be 2009. And then let's pick a scale for this axis over here. Okay, 12% for, what do you want to count each box as going up this way? How about, like, can we do 2? 2, okay? So let's call this right here 2004, and we'll call this 12% right here. Okay? And a lot of times they'll use a little squiggly line to indicate it doesn't start at 0 there. But so we have a point here at 2004, 12, and we're going to go up every 2 boxes like that. This is our guest lecturer for today, Miss Lindgren. Okay. She's leaving now. Okay, and so, so then in 2009 it got to 18, so we could put a little mark there, okay? And then in 2012 it had reached 22, so we're going to go, so if this is 9, 10, 11, 2012, I need to go up to, so this is 18, right? 20, 22. Does that look like a linear relationship? Does it look like a linear relationship? Yeah, okay. And so then I could take a line, and I could draw a line through those points going like that. And I could use that to interpolate and extrapolate. Right? So let's try to do that. Uh-oh. What's that? Estimate the number of students enrolled in the class in 2007. Who can tell me how I could do that? If this is 2009, right? 2009. Go ahead. How about Charlie?
Like you could go back 2
Yeah.
years from 2009.
Which would be right here.
Yeah, and then go up.
Up to
and
the
see-
graph.
Yeah, and see where the point is and see what percentage.
So where would I find, how would I, so I'd go up like this, right?
Yeah.
And then where would I go?
You'd stop at the red line
And I'd go which way?
and to the left.
And I'd go across, right? And I'd see that it's somewhere close to 16, right? Maybe like 15.5% or something like that. Yes? You get that? About, so that's about 15.5%. So it says an estimate, so you could do it like that. Questions? Easy enough? So that would that be an example of interpolation or extrapolation? That's interpolation because it's in between 2 points that you're given. Okay?
Extrapolate from that, right?
You could extrapolate from that. I think that's the next question, isn't it? Because on the next question it says, what does the next question say? It says, predict the percent of students enrolled in a music class in 2015, right? So if I go back, if I did extrapolation, I would come over, this was 2012, right? 2013, 2014, 2015, I'd go up, and then I'd come over, okay? And I'd say, okay, that's, what's that? 12, 14, 16, 18, 20, 22, 24, somewhere below 26, right? Questions? Okay. So maybe in 2015, you're at about 26, okay? 26%. What is the year? So this is kind of going backwards. In what year is the percent of students enrolled approximately 14%, right? So in that case, I'd have to go back. How would I do that? How would I do that? Go ahead, Nick.
You just go to 14 when you slide over.
You go to, so in that case, you go to 14, and then you go down, right? So you kind of go from the top and go down. And if this was 2000, what year was this? 2009, 2008, 2007, 2006, right? Get that? Easy enough. Have you done this stuff before? You've probably done this before. But you didn't call it extrapolation, and maybe you didn't call it that. So that'd be about 2006. Use the graph to answer the following questions. Let's see what's next. So this graph, so in this one they give you a graph, and this is not exactly a linear graph. By the way, do you think that relationship is truly linear? Do you think that student enrollment would just keep going up forever and ever and ever and ever and ever and ever? Why not? Yes?
Because it can't go past 100%.
Can't go past 100%. And at some point, you're going to reach kind of like a saturation, like only so many kids are going to enroll. That's like people who like play the stock market and stuff, like I do, and I lose my money all the time. Like you see, oh, this stock has gone up, 20% every week for the last, 3 weeks or 4 weeks or something. I'm going to buy it now, but you know what happens? It doesn't keep going up linearly. Then it kind of crashes, and then I lose all my money, and then I have to sell the car, and then my children have to be selling pencils on a street corner and stuff like that to pay the bills. And, bad news, just kidding. Okay, but so just to show you, not all relationships are linear like that. So you can't have. So what is this? This is a graph of percentage of fourth graders demonstrating mathematical proficiency somewhere or other, okay? And so estimate the percentage of mathematical proficiency in the year 2004. Who can tell me that answer? Go ahead, Jessica.
32.5.
About, let's see, 2004, 32.5, perfect, okay? About 32.5. Okay? And then it says predict the percentage of mathematical proficiency in the year 2015. Piece of cake. Oh, so now we're extrapolating. Okay? Where do you think it'd be? About here? Higher? Maybe slightly higher,
41.
or something like that. So maybe about 40. Easy enough? Okay? Okay. So I think we're just going to do one of these ones on the back. We don't need to do both. Okay? Yay. So, we ready to move on to the next page? Okay. And then I'll give you some time to work. So on the back, what you have is, basically we're doing the same thing, except we're going to do it algebraically, okay? And so it says, in 1990, the national park system consisted of about 76.4 million acres. By 2009, the figure had grown to 80.4 million acres. Let A of T represent the amount of land in the national park system in millions of acres. Find T and T years after 1990. Okay? So, what I need to know is first I need to find the slope. Okay? We're going to make a linear equation like y equals mx plus b. We're just going to put it in slope-intercept form. So 76.4 million acres in 2000, in 1990. Okay? And then it says 80.4 million acres in 2009. Okay? So how would I find the slope of this line? Go ahead, Kaylee.
You would take the two of the 80.4 million acres and then subtract 76.4 from that, and then take the 2009, subtract 19.
Perfect, okay? So what Kaylee's, and you don't have to put millions because it says let A of T represent the amount of land in millions. So you just have to put the numbers themselves. So you got 80.4 minus 76.4 over 2009 minus 1990, right? And now I just have to do the math. 80.4 times 76, oh, that's an easy number. What's 80.4 minus 76.4? 4. What's 2009 minus 1990? 19, okay? So what that tells you is, in terms of interpreting what the slope means, every 19 years, you get 4 million more acres, right? And this is a slope, right? I have a y-intercept already in here, because notice that it says, let A of t represent the amount of land in the national park system in millions of acres t years after 1990. So this one's just going to start at 1990. So my starting point is going to be 1990, comma what? What's my acreage in 1990? 76.4. So that's my y-intercept. All right. So now I have an equation. Y equals 4 over 19 x. Well, oh, they want t. Sorry. They want t. And they want it like this. Okay? They want it like this. A of t is equal to 4/19ths t plus 76.4. Do you get that? So this means that the y variable is like a of t. And all this means is that acreage is a function of t. So here's your equation. How can I figure out how much land will be in the national park in 2015? Hey, how about on this side? Who could tell me how I would figure that out using the equation? Sophie. Sophie.
Yeah, when you just plug in 2015.
You wouldn't plug in 2015 because it's years after 1990. So how many years after 1990 is 2015?
25.
Yeah, you'd plug in 25. So you got to be careful with that because they want years after, and so I'd plug in 25 in there. Okay? And so I get 4/19ths times 25 plus 76.4. I got the key here somewhere because I don't want to do the math. And you can do that, right? And you would get about 59.85. But that doesn't answer the question. Does that answer the question? Oh no, I did that wrong. Never mind. Sorry. The answer was 81.7. I'm sorry. Sorry. 81.7 million acres. So that's in million acres. In what year would the land, so the next question is the one that people have more trouble with, okay? So this is when you're plugging in a value for y and you're trying to find x. Anyone know how to do that? What would I do to do this? Go ahead, Kaylee.
When you put the 89, where like the A of t.
Yeah, this is like y, right? So you plug in 89 over here, and then you just solve the equation. So you get 89 equals 4 over 19t plus, what's my y-intercept? 76.4. And then I just do the algebra, okay? I subtract 76.4 from both sides. 76.4. That gives me 4 over 19t equals, what's that? 76.4 from 89. 12.6? Is that right? I think that's right. 12.6, that's right. How do I get rid of this 4/19ths over here? Multiply by 19/4, right? Multiply by the reciprocal. Thank you, David. So I'm going to multiply by the reciprocal. And if I do that, this goes away, see? And I get t is about equal to 59.85. 59.85. But that's not the question, because the question says in what year will the amount of land be 89 million acres? How would I figure out from 59.85 what year it is? When did I start? 1990. So I need to add that to 1990. So I have to take 1990 plus, I'm going to call that 60. Okay? So it looks like in 2050, if this is truly a linear relationship, we would have 89 million acres of what? What are we looking at? Land in the national parks. But maybe not, because maybe we're gonna get some president who's gonna take away all our national parks and turn them into shopping malls. We can only hope for the best. Donald Trump would do that for us, so we'd be in good shape. Okay. He just built a big building with his name on it. Maybe I'll set. See, anyone ever been to Chicago? You see the big building, the Trump building?
It's actually not that great.
Yeah, they have this huge building and it says like Trump over there. It's huge, right? There used to be like some.
It's really, really big, but it kind of sucks.
Yeah, there's really cool buildings in Chicago. That's where my wife's from Chicago. And she says, let's put the bags in the car. Do you know what a bag is? The bag, yeah, that's Chicago language for bag. Okay, let's go get some bagel. But she says, let's go get some bagels and cream cheese. No, she didn't. Okay, so I think I'm done here. I'm going to tell you what your assignment is, okay? And you can work, okay? So I'm going to stop this. So on Schoology, I just want to show you something. So you guys, if you didn't finish the Math Excel, some of you said it was messing up on you. Send me an email, or it's open through tonight at midnight, but if you still can't get in, just send me an email. I've changed it so that when I put the assignments in, you can turn it in late for 10%. So I've left that open. Schoology's the only thing I really haven't put in the grade book yet, okay? But I updated this last night just for you guys. So I'm sorry about this, but, okay, whoops. Why does that have to have 10 degrees? Not working. Anyway, so you guys have to do page. I know that's small. I don't know why it's not letting me make it bigger. But so this is the stuff on extrapolation and interpolation. This is the bookwork I would like you guys to do, which is on point slope form. Okay, so it's not. There's no Schoology assignment for you guys, but I didn't assign that yesterday, and I think I should have, because it'll give you a little more practice on that. And it's still not that many problems. 1, 2, 3, 4, 5, 6, 7. About 15 problems. So you'll be okay. Okay? So you can go. You can't go anywhere, but you could do your work. Or you could sing songs. Or we can we answered good questions today. Kaylee answered good questions. Who else was a good Amanda was a good question answerer. David, I heard David say something. Okay. Kaylee. Charlie Bangs was pretty good. Yeah. Kaylee M. was pretty good. Amanda Johnson was pretty good. Who else answered me good questions? Will Wander answered me some good questions. So did Nick. I'm just giving you a kind of participation. Sophie Shula. Right. Oh yeah, so did Sophie. You're good. I'm just okay. So you got 10 minutes. You can work, or you can sleep like David. But get your homework done by the way. All right. Sorry. next week we'll have Tootsie Pop opportunities. On Thursday, because that's, Thursday will be review day for the test that we have next Friday. Okay, next Friday we have.
What is it on?
Figure it out at
Chapter 2, 2:1 through 2:1, 2:5, 2:1 through 2:7. So all of chapter 2 basically. And if you haven't taken that quiz, you need to come in and make it up. Here's a quiz. Oh, Quinn's still not here, but Hayden, here's your quiz. Caleb, where are you going to come and make up your quiz this week? Wouldn't it like you give any other time you could come? You gotta do that. Can you come after school any day? Not today, because I gotta, it's Friday. We don't like to stay after school on Friday, too. Yeah. We're out of here. I like to go home and eat my burrito. Friday nights are burritos nights. Do you want to hear my story about Friday night burrito nights?
Yeah.
We always have Friday night burrito night on my house. Because when I lived in California, my buddies and I, when I was younger, we'd go running, and then we would at this really nice park, and then we'd go and get burritos at this place called Bueno Burritos, and then we'd have frozen yogurt, because they not only had burritos, but they had frozen yogurt too, and it was really fun. But that's before I was married many years ago, and I was always searching for the perfect woman, and she either didn't like burritos, or she wasn't a very good runner, or she didn't like frozen yogurt, okay? And so then, I met my wife, and I said, you want to go running? And we went running, and she like kicked my butt, and then she went out for burritos, and she loved burritos, and she liked frozen yogurt, so it was like a marriage made in heaven. And then, so now we've been going out for burritos every Friday night for the last 20 years. We used to go to, and then we go to Chipotle mostly. Chipotle. And now my kids know it's burrito night. But Haley doesn't like burritos, so we get her noodles instead. Can't win. Or we go to Mod Market, which costs like 7 times a day. It's good. Yeah.
It's good.
I like my burrito.
You know, but
Claire, what are you doing this weekend? Nothing? No work? What do you do for fun? Are you in the band?
Did you know?
I play the trumpet. Did I ever show you play the trumpet?
A little while after.
Pretty good.
So we started basically.
Girls!
Russia.
Your dad, you're going to get mad at me. No?
So we set up
Did you show your dad the logic puzzle?
things that they would steal,
No, I didn't.
so that it would, it'll fall a few times, then it'll fall. It ended up flooding a ton of
Yes, ma'am.
blew up
so
everywhere.
it's basically I just half US credit, but I just also US gave away all more than their access to credit.
Thanks.
6, 7, 8, 9, 10, 11, 12, 13, 16, 17, 18, 19.
I was gonna message him.
I used to have a cup station. I like it.
I cannot think that.
It'll be
Okay. I'm gonna close this.
Let me do this, I don't wanna crash my graphics.
Help them do that.
Did it so fast, like, look.
Whoa, someone's yelling at me. Oh no,